In this video, we're going to be working on the Focusrite audio interface. In this repair video, we're going to be working on the Focusrite audio interface, and the unit looks something like this. I honestly do not know why the customer mailed this unit over. I never worked on this, and I do not know what's inside. I looked inside the box, and the customer also mailed over 3 chocolate bars. I already ate this bar. There's one small piece left, and I have 2 more to go. This one looks deformed from here. That's not good. I'm not going to give this unit my 100%, unless, of course, the customer mails over more chocolate. Let's read what the customer wrote so we can have an idea of what's going on. The device no longer powers on after having accidentally used a 24-volt power supply instead of 12-volt power supply. I took a look at the circuit and had some strange readings on C333 capacitor right in front of the power input. I removed it and then started getting readings of a short circuit down the power line. I figured I'd stop there and let someone with better knowledge and experience figure this out. I live in Hershey, Pennsylvania, and I thought you would enjoy some chocolate from my town as a little treat. I'd also love for you to take a look at the device on video and YouTube. I watch your videos whenever you post and have learned a lot from them. Thank you so much for providing such a great learning tool for everyone. Thank you so much for mailing over the chocolate, and that's the only reason why I'm going to be working on this device right now and posting a video. Hopefully we can figure it out. One thing that bothered me though is the C333 capacitor. Customer tampered with the C333 capacitor. I do not know which one the capacitor is. I hope there's no serious damage there. But let's take a look. The customer plugged in a 24-volt power supply instead of 12, and the unit stopped powering on. I do not know if there's some type of fuse that we can look at. Probably not, but we'll see. Right now, the power adapter plugs in right there. So I'm interested in this part of the circuit, right here. Let's take a look and see what's going on. So our power adapter, oh, right there, C333. Our power connector is right here. And customer completely removed this capacitor. Why? Why? We do not have a circuit diagram for this device, and there's absolutely no way to find the value of that capacitor in any way, shape, or form, unless we have a similar device that we can test that cap on, or unless we have a circuit diagram. I have no clue what this part is, what this capacitor is, what's the value of the capacitor, what's the size of the capacitor. No way. I do not know the purpose of that capacitor on the circuit, but we're going to leave it empty for now. We're going to do a quick visual inspection. Maybe we can remove this cable, and this cable looks like a switch. We have a switch right over here, and that switch has a cable that connects to the board to flip the power on or off. Let's remove it for now because I want to be able to clearly see what's going on this board. And let's do a quick visual inspection. See if there's anything obvious or anything blown or anything burned or anything missing. I'm not going to go too far. I just want to stay within the boundaries of this power connector. We have more caps here, and none of the caps are bulging, or none of them look burnt. But a capacitor does not have to look burnt to be good, to be bad. We have a diode here. I mean, right now nothing stands out as being faulty by just looking at the board, except for that missing capacitor that the customer decided to take out. I do not know why the customer took this capacitor out. Was it short into ground? Was it blown? Was it burned? If not, then there's absolutely no reason why this capacitor would be taken off the board, knowing that we can never figure out the value of that capacitor. I mean, those caps are tall, so it's a little bit hard to get the probe on here. I'm reading nothing, so that's good. We do not have a short. We do not have a short. What if we read at this cap here? Nothing. I'm telling you, it's very hard to get the probe inside here. It's actually impossible. Right there. We do not have a short. We do not have a short. So that capacitor should not have been taken out unless it was blown or burned or a hole in it. Let's apply 12 volts onto the connector, and maybe we can monitor the board under a thermal camera and see if anything gets hot. I have a power cable here. It's a power cable that we sell with our laptop charging kit. It looks something like this. The kit comes with 2 cables, but you can buy extra cables with the kit. So that's what I use, and it fits perfect here. I'm gonna connect this wire to my 12 volt probe, and ground is connected to the ground wire of the cable right here. And what happens if we power the device on? Actually, the device was on, and we did not have any amp draw. Let's make sure we have a good connection. Okay. Now we're gonna switch the device on, and nothing. Oh, wait a minute. Nothing because I removed the switch cable. Huh. Let's put that switch cable back, but turn it off. Of course, the switch is not gonna work if the cable is not connected to the board. All right, let's try it now. Hopefully nothing is gonna blow up. Whoa, 4 amp draw. Right off the bat, 4 amp draw. I switched the unit on, 12 volts at 4 amps. Wow, so we definitely have a short somewhere on the board. And right now, wow, this board is hot. Wow, very hot. Where's our thermal camera? Heat is good. Heat is very good, because we can see it under the thermal camera and we can pinpoint where heat is coming from. Because right now, by the naked eye, we're not going to be able to figure out where the problem is coming from unless we test every single component, every single capacitor. And even after testing all the capacitors, some capacitors are in parallel, and it's going to be hard to figure out where the short is coming from without a thermal camera. Thermal camera is a priceless tool. I bought the battery for this thermal camera about 6 months ago, and it's not lasting more than 20 minutes. I did make a video on the FLIR thermal cameras, how expensive their parts are. The battery is about $150. I got this one for $60. But what good is it if it only lasted a few months? Let me charge the battery for a few minutes, and I'll be back. All right, so I have the thermal camera on, and let's go ahead and power up this unit. 1, 2, and whoa, whoa. One more time. It's off right now. The unit is generating a lot of heat, and we do not want to keep it on for a long time, but let's try to pinpoint where the short is coming from. And right now I'm using a plastic spudger. We should not point with our tweezer over those capacitors. And this spudger is, what, 75 cents. You can find it on our site. It's called ESD plastic spudger. Let's do this one more time. Turn the unit on. Let me flip the board and look on the back. And right there we do see a heat spot right here. Heat spot exactly right here. Okay. Let me quickly mark it with a pen so we do not forget. heat spot is coming from right over here and here. Okay, off. And look at this. The voltage injection tool is smoking. 12 volts at 4 amps. Look at the smoke. Maybe the cable could not handle 4 amps at 12 volts. I kept it on for a long time. I should not have done so. If I'm injecting a lot of amps at a lower voltage, maybe that's fine, but right now I pushed it to the limit. 4 amps at 12 volts, that's a lot. Let me turn the fume extractor on. And let me turn the unit on to see if it's still working. Yes, the unit is working, no problem. All right, so let's take a look at where we circled. And right now we do not need to inject voltage anymore. We already know where heat is coming from. And if you look here, heat was coming from this area and from this area. So what's here? We need to flip the board to see what's on this side of the board. Okay, so the area I circled is likely pointing to this capacitor right here. Actually, it's pointing, from what I can tell, right here, but there's nothing here. We already measured this capacitor, and it's fine, and we already measured this component also, and there's no short. That's an inductor, so an inductor is not going to short out. So that leaves us with the closest component to this area, which is this capacitor here. Let's flip the board and see where this capacitor leads to. And so we can measure it, those two leads. Let's measure in continuity mode and see if we have a short on this capacitor. If yes, then most likely that's our problem. This cap is shorting to ground. 0 ohms. That's short. Beautiful, beautiful. Look at that wick. Look at that wick. Okay, right there. Got it. And let's take a look at this capacitor under the microscope. And if you look here, 220 microfarads at 50 volts. Caps con. Caps con. Can you spell it? Cap X on. After measuring the capacitor, the camera went off. The cap is not shortened to ground. So let's go back here where that heat spot was. What if we measure this capacitor? We have a short on this cap. Really? I mean, I thought I measured this capacitor before and we did not have a short. Meter in diode mode. We do not have a short to ground, no. I'm just looking at the circle I did on back of the board and I'm trying to map it to front of the board, and the only thing I see on front of the board is the inductor and capacitor. Right here. Inductor, capacitor, or possibly this diode. Let's measure in diode mode. And let's flip the probes, measure again. And we have a short. We have a short. What if we point the red probe on ground somewhere on the board and then measure this diode? We do not have a short. Okay, I think what we're gonna do is use the atomizer, and I'm gonna apply some rosin flux powder right over here. Okay, so the coil looks like it's getting hot. The coil. Okay, so right now I'm not able to figure out the short. It's 8 o'clock and I do not want to spend any more time on this one today. I'll leave it on the bench. Maybe I'll continue working on it tomorrow. I'm back. I left this on the bench yesterday. It was 8 p.m. and the wife was calling for dinner. So I did not want to spend any more time on it. I thought, let me come early today. I'll work on it some more and see if we can figure it out. I did not hit the record button. I thought, let me figure out the problem and then I'll tell you what I figured out. Let me show you what's going on. Right now you see a desoldered, cracked diode and a desoldered inductor. And the inductor is labeled by L21. And we have a diode here, and you can tell there's a crack in that diode. But let me start from here. We removed this capacitor. We thought that we may have a short on this capacitor, but the cap is good. We do not have a short here. So I kept the cap off so we can make room to desolder this component, because the diode was measuring continuous on both ends. Red probe here, black probe here, continuous, vice versa, continuous. So the diode is bad. As soon as we applied heat to remove that diode, we found that crack. It cracked in half. So the diode is faulty. Diode can be changed, and we can look up the number on the diode and possibly figure out the value of that diode. Now, the interesting part is the inductor. The problem is not only caused by this faulty diode, but it's also caused by the inductor. Because after we removed the diode, I plugged the power cable and we still had a 4 amp draw, a 4 amp short. So I proceeded to remove the inductor and the short is gone. I never worked with this component before, so I do not know what this component is or the value of the component. We know it's an inductor because of the L21 marking on the board, but I do not know the value of the inductor or what the inductor is called. Now, the interesting part is after I remove the inductor, let's plug the power switch, and I'll tell you why the problem is this inductor. Coils do not usually fail when the coil has 2 ends, but this coil has 4 pads. And I'll explain why I think the problem is this inductor. Let me plug the power switch. It's plugged in, and let's apply power. The power cable is plugged in and on. We no longer have a short. Okay? Of course, we no longer have a short because the inductor is what makes voltage go from one end to another, right? But that's not why we do not have a short. Let's go back to the microscope. Right now it looks like we have plus 12, minus 12, or maybe it's plus 12 and minus 12. So what's happening here is positive 12 is shorting out with negative 12. Instead of 12 being passed here and negative 12 being passed here, the inductor has a problem where it's shorting plus with minus. If I measure from here to here, we have 11.86 volts. So we know that one end is plus, one end is minus, and plus, this one is plus. Plus is passing all the way here, and minus is passing all the way here. The inductor is shorting out this with this. And that's a faulty inductor. That's our problem. Let's flip the inductor. And we can verify this by measuring those 2 pins or those 2 pads. Meter in continuity mode. Look at this. So everything is shorting to everything. Plus is being shorted with minus. That's our problem. Right now, the bigger problem is we do not know the value or the model number of the inductor. There's no way to know the value or the model number of the inductor unless we have a circuit diagram or unless somebody specifically know what the value is. I'm sure we do not have any circuit diagrams for this device. Otherwise, it would be easy to figure out what that component is. Right now, the only way to get that component is if we have a similar donor board that we can extract components from and possibly fix this device. I do not know how much this device is. Probably a couple of $100. But aside from the point, that's the only way to be able to fix this device. That's it. We're going to end the video right here. Let me know what you think. Leave it down in the comments. I hope you enjoyed the video. Don't forget to like and subscribe. Leave a comment if you have any questions. And we'll do something else in the next video.